Hello everyone, welcome to Evolkai, a machine learning community for machine learning enthusiasts. Now today, we will be learning about random forest classifier. So what is it? So random forest classifier is an ensemble learning technique. Now, as told in my earlier videos, ensemble learning is nothing but a combination of many other different machine learning models. So, what is random forest? Random forest. The name suggests forest. It is a combination of trees. Forest is a combination of trees. So, we can say that random forest is a collection of decision trees which comes together, combines, which makes an ensemble learning technique and make predictions. Each tree is trained on a random subset of the training data. The training data is divided into many decision trees which then splits the data into further subsets, and the final prediction is determined by the aggregate prediction of all the trees. Now, this approach reduces the overfitting and improves the accuracy. Random forest classifier can handle both numerical and categorical data and is said to be very good while working with large and complex dataset. It can handle complex variables very easily. This type of this type of machine learning model has uh, is used for classification tasks in various domains such as finance, healthcare, and marketing, which are the primary domains in our society. Now, it is known for its robustness, interpretability, and ability to handle complex relationship between variables. Now, let us understand random forest classifier by this diagram. So, on the left side we have decision tree and on the right side we have random forest. So, this is what a decision tree looks like. As told in my decision tree video, a decision tree splits the main data into subsets, then further split that subset into further subsets. So, it forms a tree, and then each and the data is passed through each branch to make predictions, while in the random forest these multiple trees are used in the random forest, and the training data is splitted between these decision trees, which further splits the data into branches. And then uh, using the aggregate prediction, the prediction is made on the data. Okay, so let's come to the practical part. We will just give it a fast go, and we will go to the visual studios to get a practical knowledge. For the slide we will use iris dataset, and for the practical we will use p1 dataset. Though I have shown the working on iris dataset on my earlier videos with different models, so if you want to see those models you can check it on YouTube or our website. Okay, so first we will import pandas library, and we will use read CSV function to read the dataset. We will take the information of the data, and this information will tell us about the data type that the data set have. The It also tells about the memory that the data set is consuming, and if any null value is present or not. Then we will specify the features and prediction class. Now for the simplicity we have given it like this, though this is not a good practice. What actually programmers or machine learning engineers do, I will show you in the VS Code. So we will define the features and prediction class. So features is nothing but the input data that the user will provide, and prediction class is not is that variable that our model will predict. Like in the iris dataset, the features will be sepal length, sepal width, petal length, and petal width. And on the basis of this data, our machine learning will predict the species of the flower. Okay, so we will put the features data into x variable and prediction classes data in y variable. Now we will split the data into training and testing parts. Now it is a common sense that if a machine learning model is trained more, then it will yield more good results. So we will keep the testing and training size in the ratio 3 is to 7. But if you want to if you want to decrease it, the data set will give a good result. But as told earlier, that more you reduce the test size, more your model will be prone to overfitting. Though random forest classifier has its own benefit, that overfitting does not affect it very much. Now we will check by printing the shape of the X test, X train, Y test, and Y train, that if the data has been splitted properly or not. Now we can see here that the training data is more and the testing data is less. So we can say that the training test split has done its work properly. Now this is the main part where we will import random files classifier from Ensemble library, and we will assign this model to a classifier, and we will fit the model or the classifier with the training data. Now on the basis of this model, we will predict the values of bipred using the X test. Now, the thing here is we will import the metrics from sklearn, and we will predict the accuracy score based on Y test and bipred. Now for each Y test value, if Y test and bipred are same, the accuracy will increase. If Y test and bipred are not same, then the accuracy will decrease. So for iris dataset, we will get an accuracy of 95.55, which is pretty good. Now let's go to our Visual Studio's screen, and we'll deal with PyMass dataset. Okay, so we have come to our Visual Studios. Now I'll show you the practical implementation. So we will first import pandas library. We'll read PyMass diabetes dataset. So let me give you a glance. So this is PyMass dataset. It has columns like pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and outcome. So outcome here will be that if a person has diabetes or not. So 1 suggests that the person has diabetes, and 0 suggests that person doesn't have diabetes. So now we will just go back to the code snippets. I'll just store the data into the data variable, and we'll get data info. So let's see. There are total 768 columns, and each data has a non-null, not null. That is, values are present in the cell. The data type of the data is integer, and for the BMI and diabetes pedigree function, it is float. Now, in the in X variable, we will store that we'll store all the columns except outcome. That will be our prediction class, and the rest will be our features, that is pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. This will be our features, and prediction class will be our outcome. So we'll store the data of the feature class in X and the prediction class in Y. Now we'll run the data, and we'll import train test split from sklearn.model selection, and split the data into training and testing part, where the test size will be I have taken a 20, I can take a 30, whatever is needed. I'll run the data. I'll run the cell, and I'll check if the data has been splitted properly or not. So the training data has like 500 entries, and the X test has 200 entries. So the data, I think, has splitted properly. Now we will import random forest classifier from Ensemble library, and we'll assign this model to classifier variable and fit the data with X train and Y train, and we'll predict the data on the basis of this model in Ypred. Okay, so it didn't took time since the data is very short. Now we'll print the accuracy. So the accuracy we achieved is 76. Now this accuracy for this dataset is quite good, since if you have seen my earlier videos where I have used the PyMass dataset, the accuracy we are getting is somewhat of the same range. So we can say that this data set is accurate only 76%. Like every time it won't be able to tell you that the data that the person has diabetes or not correctly. Okay, so this was it. Now we will go back to our slides and conclude the video. Okay, so now we will conclude our video by giving a short conclusion on random forest classifier. So as discussed earlier, it is a very powerful classification tool. It utilizes ensemble technique of decision trees, which combines different types of decision tree and bring it into one and predicts the data. It is not prone to overfitting. It mitigates overfitting. Algorithm is versatile and handles various types of dataset, complex and large dataset effectively. It finds the application in diverse domains such as healthcare, finance, and marketing. This classifier also deals with the problem of complex variables. That is, if the data is too complex, the random forest classifier isn't affected with that. Okay, so by this, we will finish our video. So thank you for watching and uh, happy learning.